Hello, pre-calc students. Right now we are doing vectors, and I'm doing a video lesson on the lesson today, just in case you missed class or just missed some material during class. I know I didn't cover everything. So vocabulary: a scalar is a quantity with magnitude only. So for example, a car moved at the speed of 25 miles per hour, and a vector has both magnitude and direction. So example, a car moved at a speed of 25 miles per hour in the direction of 60 degrees north of west. And vectors are drawn tail to tip. So they're drawn tail to tip, and vectors also have horizontal components. So they have a horizontal component. The horizontal component is I, and then you have a vertical component. And a vertical component is J. So moving, and I is this is just math terminology that they use. They use I for vertical components and J for horizontal components. The vectors are drawn tail to tip. Okay. So let's add some theoretical vectors here. The sum of multiple vectors is called the resultant vector. The resultant vector is found from placing all vectors tail to tip and then drawing the resultant from the tail of the first to the tip of the last. So we'll set the resultant of each set of vectors. So to find the resultant, you go from the tail of the first to the tip of the last. What you can do is tail of the first to the tip of the last. So that is the resultant vector. All right, with this resultant vector, I want you to note that the order that you're adding up these vectors doesn't matter. Instead of starting with this vector and ending with this vector, I could start with this vector, end with this vector, and if you notice, the resultant vector pretty much it's starting in it's coming from the same place. So let's use this example. You can still do it with 3. Just let's move this vector. Tail of the first to the tip of the last. If I can move this, all right. So this vector would start at the beginning of the first and move to the end of the last. So this would be the resultant vector, okay? Now, I want you to, once again, let's experiment showing us that it doesn't matter what order you put the vectors in. So it's with this vector here, and this vector right here. And you even though I changed the order, it still looks like you can get your resultant vector. All right? So that's conceptualization for vectors. All right? We have our compass directions. Due east is 0 degrees, 360 degrees. Due north, that's going to be 90 degrees. West is 180 degrees. South is 270 degrees. So 0 degrees and 360 degrees. 90 degrees. 180 degrees. 270 degrees. 33 degrees west of south. So we're 33 degrees west of south. So what we're going to do, move south. We're going to start at south and go 33 degrees west. So we start south right here. Remember, when we start south, we're at 270 degrees. And then we go 33 degrees to the west. And so you're ultimately going to get this angle right here. And this angle is going to be, remember this angle, that's 180 right there. And then we're going to add an extra value to get right here. So you can do 180 plus this value, or you can just do 270 minus 33. That's what we're going to do. 270, that's our angle value from south. And we're moving west, which means we're moving clockwise. So we subtract 33 degrees. So 270 minus 33 is going to be 237 degrees. So this would be 200. So this is going to be 237 degrees. Add 3, 240. 40 plus 30 is 270. 60 degrees east of north. So we start north. In this situation, we start north, so we're going to start at 90 degrees. We're starting at 90 degrees. And we're moving 60 degrees east. So we move 60 degrees east. Remember, this is the east direction, so we're moving 60 degrees east. This is going to be 90 minus 60. So 90 minus 60, that's going to be 30 degrees. 22 degrees east of south. Let it load. We're 22 degrees east of south. We're going to go south, move up 22 degrees in the east direction. That's going to be 292 degrees. 32 degrees west of north. Start north, move 32 degrees in this direction. That's going to be 90 plus 32. That's going to be 122 degrees. 33 degrees south of west. So we're going to start at 180 here. Move 33 degrees in this direction. That's going to be 180 degrees plus 33 degrees. That should be 213 degrees. 60 degrees north of east. So we start east, move 60 degrees north. So that's just going to be start at 0, add 60. It's going to be 60 degrees. Notice when you're at east, if you're moving north, you start at 0. If you're moving south, you start at 360 because you're subtracting. 22 degrees south of east, now instead of going north, we're moving south 22 degrees. That's going to be 360 minus 22, which is going to be 338. 32 degrees north of west. So we start at west, that's going to be 180 degrees. 32 degrees north, so that's going to be 180 minus 32, and that should be 148 degrees. Clear annotations, all right? So hopefully this visualization helps you out, but you just got to be able to conceptualize this. All right. Right triangle vector problems. A small motorboat, which maintains a speed of 10 miles per hour in still water, is traveling due west across the river. So we have our motorboat. And our motorboat, first, part of how it's traveling is it's faced in the west direction and it's moving at 10 miles per hour. So it really is moving at 10 miles per hour here. That's one component of its movement. The other component of its movement is that the river has a current 4 miles per hour north. All right. So we have a current that's affecting the position of the motorboat that's going 4 miles per hour north. Okay. And so west is going to be in the left direction. North is going to be in the up direction. So now we have ourselves a question. What is the true speed of the motorboat? What about its direction? So the true speed of the motorboat and its direction is going to be the resultant vector of our westward movement and our northward movement. So we're going to start here where the motorboat starts. This is where the motorboat finishes. And this is our resultant vector. Okay? And we have ourselves a right triangle, okay? Let me change where I have this motorboat label here. So we have this is our starting point for our motorboat. Now, the speed is going to be the magnitude. This is the magnitude. And the angle from our starting point to our ending point is going to help us determine our direction. Okay? So to find the magnitude, to find the speed / the magnitude, we're going to use the Pythagorean theorem. Notice we can create a right triangle here, right? So we can find the magnitude using the Pythagorean theorem. A squared plus b squared is equal to our speed squared. 10 squared plus 4 squared is equal to our speed squared. So 10 squared is 100, 4 squared is 16. 116 is equal to our speed squared. So our speed is equal to, take the square root of each side, the square root of 116, which is going to be equal to 10.77. So our magnitude is going to be equal to our speed / our magnitude is going to be equal to 10.77 mph. So equal to the square root of 116, or approximately equal to 10.77. This is magnitude is approximately equal to 10.77. Now I'm also going to have my direction, okay? And to find the direction, I can use my properties of the tangent function. So I know that the tangent of theta is equal to the opposite side over the adjacent side. So the tangent of theta is going to equal 4 is the opposite side. 10 is the adjacent side. Remember, 4 is the opposite side. The opposite side. 10 is the adjacent side. And to find theta, I can take the inverse tangent of each side. So the inverse tangent of the tangent of theta is equal to the inverse tangent of 4/10. The inverse tangent of the tangent of theta, that's going to be equal to theta. And that's going to be equal to the inverse tangent of 4/10. So theta is equal to the inverse tangent of 4/10. And one property you have to know is that, remember that the composition of a function and its inverse of a function and its inverses, inverse, not inverses, produces the original input. So that's just one good note to know. So theta is equal to the inverse tangent of 4/10. So get my calculator, make sure my mode is degree mode, and I find the inverse tangent of 4/10. The theta is equal to 21.8 degrees. But we're not done yet. So theta, this theta is equal to 21.8 degrees. But we're not done yet because we need to find the direction. And notice we're moving west and north. And when you're moving northwest, you're in quadrant 2. Quadrant 2 angles are in between 90 and 180. 21.8 is not in between 90 and 180. So that's our reference angle of our triangle. If we're actually looking at the angle of our triangle, we can find it by doing 180 minus 21.8. So looking at kind of the XY axis here, if this value is 21.8, our actual value of our angle is going to be this value right here. And then you can find this angle by doing 180 minus 21.8. 180 minus 21.8. So that should be 180 minus 21.8. That will be 158.2. So our actual direction is going to be equal to 158.2 degrees. That's approximate. That is our magnitude and a direction. What would be the speed of the motorboat if it traveled due north? That's going to be 10 plus 4 equals 14 miles per hour. And here, this would be 10 minus 4 is equal to 6 miles per hour. And this is because here the motorboat and the current would be perfectly in sync if they're traveling together and be going perfectly against each other if they're going in opposite directions. Okay. Moving on. A pilot aims his plane, and actually, let's keep the continuity. A pilot aims her plane due south at the speed of 580 kilometers an hour. If the wind is blowing at a speed of 48 kilometers an hour due east, what is the resultant speed and direction of the plane? So we're going down (580 kilometers per hour). Then so that's how the plane is being aimed. We also have a wind blowing 48 kilometers due east. This is not to scale. This is going to be, that's a 48. It's going to be about 1/10, a little bit less than 1/10. So you're going to have 48 kilometers an hour. And then you're going to have this is your end point of the two vectors. And we go from the tail of the first to the tip of the last. So this will be our resultant vector right here with our theta value. And I want you to notice something, that if we start right here, already this rotation right there we're starting right here at the negative y-axis at 270 degrees. So just making a quick note of that. Keep that in the back of your head. So let's need to find the resultant speed. To find the speed, use the Pythagorean theorem. So 580 squared plus 48 squared is equal to the speed squared. Simplify this. Your speed is equal to the square root of 580 squared plus 48 squared. So let's get out that trusty calculator and do find the square root of 580 squared plus 48 squared. That's going to be 581.98. So our speed is going to be equal to 581.98 kilometers per hour, and that's going to be this magnitude right here. 581.98. All right, so that's our speed. Let's find the direction. For our direction, first we need to find theta, not our angle of direction, just theta, the internal part of this right triangle. So theta, to find theta, theta will be equal to, this is the inverse tangent of the opposite side over the adjacent side. So the inverse tangent of the opposite side is 48 over 580. So let's calculate that. We find the inverse tangent of 48 divided by 580. That's going to be 4.73 degrees. So theta is equal to 4.73 degrees. We're not done yet. We still need to figure out what our actual direction is. And if you notice, this theta is to the right of the negative y-axis. So remember, we've already rotated 270 degrees to get to the negative y-axis, and then this angle right here is 4.7 degrees to the right of it, okay? So that's a counterclockwise rotation, which is a positive angle rotation. So that means our direction is going to be 270 degrees plus 4.73 degrees. So direction is going to be equal to, what's Box's speed? 274.73 degrees. That's our direction. For further visualization, this has to be in quadrant 4, right? We're going south and east. When you move south and east, that puts you in quadrant 4, right? Out of the 3 quadrants. So you need to have an angle that is a quadrant 4 angle. So once again, first you move south, then you move east. So your angle is going to be south, east of south. So think about it. This is, for compass direction, this is going to be our direction. It's going to be 4.73 east of south. Okay? Now, how far south of the plane have traveled after 3.5 hours? Now, we know that the vertical component of the plane, so J, the vertical component of the plane, so this is going to move south at, and it's just given to us, 580 kilometers per hour. So in order to find this value, we have 580 kilometers per hour times 3.5 hours to find our how far this plane is, how far south the plane has traveled. So we have 580 times 3.5. That's going to be equal to 2030. So we're going to say 2030 kilometers south. So that's how far south. If the pilot's destination is due south from where she started, how off course is she? So let's break this down. We essentially draw a triangle with our new values, okay? One thing you need to know is that if we expected to get to arrival after 3.5 hours, if this is our southward component, so we have (2030) as a southward component. We still have our angle. I'm just drawing it bigger so I can write it down at 4.73. So our angle here of 4.73 degrees, not to scale. And this is after 3.5 hours. To find this magnitude, we just have to do 581.98 times 3.5. So let's do that. 581.98 times 3.5. That's going to be equal to 236.93. So if that value is 2030, this value is 236.93. This value is 236.93. And we need to find out how far off course. So if there's not supposed to be any wind, the pilot was supposed to end up here. But the pilot ended up right here. So we need to find out how far off course she is. And so this distance in the triangle is how off course the pilot is. So we need to find this value x. And notice this is a side angle side triangle. This is a side angle side triangle, which means we can find x. Find x using the law of cosines. All right. So for law of cosines, we have our non-included side and included angle, the side we need to find. So we know that x squared is equal to 2030 squared plus 2036.96 squared minus 2 times 2030 times 2036.96 times the cosine of 4.73 degrees. So plugging in the law of cosines, and so that means just to find x will be equal to the square root. We're going to have a big square root of 2030 squared plus 2036.96 squared minus 2 times 2030 times 2036.96 times the cosine of 4.73. All right, let's hope this restart doesn't mess me up. So I get my calculator and find the square root of 2030 squared plus 2036.96 squared minus 2 times, let's put things in parentheses, 2 times 2030 times 2036.96 times the cosine of 4.73. Plug it all in. I'll get 167.96. So x is equal to 167.96, so 167.97 kilometers away, kilometers off course. All right. Next slide. A ferry boat wants to reach its destination directly north across the river from its starting point. The ferry travels 18 miles per hour in still water. If the current is flowing at a speed of 7 miles per hour due west, at what angle should the ferry captain aim her boat? All right. So let's start here. We know one component is 7 miles per hour. This value is going to be 7. We know that the ferry has initial propulsion of 18 miles per hour. We want the ferry to reach a destination directly north from its starting point. So we want the ferry to end up somewhere directly north. This is our ending point. We don't know this direction. Magnitude is questionable. And we need to know what angle should the ferry captain aim the boat, okay? So we know we have to start at the end of our westward vector, move here, and know that our ferry boat has a magnitude of 18. So this value is going to be 18. And we need to find this missing side. So if you can draw this, this is the current. This is the starting point. Our end is directly north from the starting point, and this is the movement of the boat from the current. We need to figure out this is the movement of the boat from the motorboats, or the ferry boats movement. So we use a Pythagorean theorem to find out. So we need to figure out what angle we should we aim the boat, okay? So we actually don't need to know. We could find the Pythagorean theorem to find out the question mark. We need to find out this angle, what angle she's aiming the boat. So I'm going to say the cosine of theta is the adjacent over the hypotenuse. And here the adjacent side is the current. The hypotenuse is 18. So the cosine of theta is equal to 7 over 18. The cosine of theta is 7 over 18. Then theta is going to be equal to the inverse cosine of 7 over 18. And get the calculator, find the inverse cosine of 7 divided by 18. That's going to be 67.11. So theta is equal to 67.11. I want you to note here that we're moving for this boat, or at least for this angle, when we're looking at this angle right here, because that's the angle, that is a quadrant 1 angle. So we don't have to adjust the angle to a new quadrant. I can immediately tell that value starting from the positive x-axis, that is going to be equal to 67.11, and we don't have to change it. So we don't have to adjust already in quadrant 1. Don't need to adjust. We are already in quadrant 1. And so therefore, we can say that the direction, so that we can say that the ferry captain should aim her boat (67.11 degrees). And you don't have to specify, but you can say north of east. All right. So let's do our 2 non-right triangle vector problems. A pilot flies his plane due west for 150 miles. All right. So then turns 42 degrees north of west for 70 miles. So check your own for your application, but 42 degrees north of west means that this angle, this angle right here is 42. If this angle, so that's not 420, it's 42. This angle is 42 degrees. This angle right here is going to be 180 minus 42. 180 minus 42 is going to be 138. So this angle is 138 degrees. So this is 138 degrees. We need to find the plane's resultant distance and direction from its starting point. So we need to find this. This is the resultant vector. We need to find this angle, okay, and this distance right here. So we need to find this direction and this magnitude. And note right now, you can see that this angle is a quadrant 2 angle. So to find the actual value of our of the direction, if this value is theta, right now I'm going to say for the direction is going to be 180 minus theta. Theta is the internal angle of the triangle. Okay? So, that being said, we can find our magnitude using the law of cosines because this is a side angle side triangle. So to find the magnitude, we use the law of cosines. And we do find the magnitude first. All right? And so I know that let's call the magnitude m. Once you get used to that law of cosines, you can say m is equal to the square root of, and this value is 70, 150 squared plus 70 squared minus 2 times 150 times 70 times the cosine of 138 degrees. So let's get our calculator and say that m is equal to the square root of 150 squared plus 70 squared minus 2 times 150 I want to put this all in parentheses just to be safe. Minus 2 times 150 times 70 times the cosine of 138. Plug that in. So I can get our magnitude of 207.38. So magnitude, our magnitude m is approximately equal to, what's that value again? 207.38. 207.38 miles, which is approximately equal to our resultant distance. From here, we can find our direction. And our direction is going to be, remember, 180 minus theta. So now we can find theta. To find the direction, we can use the law of sines. So we can find theta. Now we know the magnitude is 207.38. We can say that the sine of theta over 70 is equal to the sine of 138 degrees over 207.38. Isolate sine of theta. The sine of theta is equal to 70 times the sine of 138 degrees over 207.38. So theta is equal to the inverse sine of 70 times the sine of 138 degrees over 207.38. To find theta, we're going to have to pull up our calculator. We find the inverse sine of 70 times the sine of 138 degrees divided by 207.38, and we're going to close off the parentheses, and we're going to get 13.05. So theta, this theta right here, is equal to 13.05. Remember, our direction, we originally established this is the second step, is 180 minus theta, so that's 180 minus 13.05. So our direction is going to be 180 minus 13.05. That's going to be 180 minus 13.05. That's going to be 166.95. So that's our direction. Our direction is going to be equal to direction is going to be equal to 166.95. So that's the magnitude, that's the direction. All right, last problem. All right, a runner runs at the speed of 3.8 miles per hour for 40 minutes due east. So we're going to start here. Now, 3.8 miles per hour times 40 minutes, that's going to be times for 2/3 of an hour. That's going to be 3.8 times 0.66. 3.8 times 0.666, because I add a bunch of sixes. There's going to be 2.53. So that's going to be equal to 2.53. So we're going to move east 2.53. Then we're going to turn 30 degrees south of east. So we turn 30 degrees south of east. So starting right here, we're moving east, but then we can turn 30 degrees south of east. So that means this angle right here this angle is 30 degrees, which means our internal angle is 180 minus 30 degrees. So this angle is 150 degrees. So this angle is 30 degrees. This angle is 150 degrees. So south of east. So this is east. We rotate 30 degrees south. We're looking for the inside of the triangle. So this is 150 degrees. And then we move 5.2 miles per hour for 20 minutes. So 5.2 miles per hour times 20 minutes, that's 1/3 of an hour. Get out our calculator. 5.2 times 1/3. Add a bunch of 3's to be more accurate. That's going to be 1.73. That's going to be approximately equal to 1.73. This is going to have a magnitude right here of 1.73 miles. How far is she from the resulting starting point? Well, if we make this completely not to scale, it's going to be this distance right here. So we need to solve for x. So x is going to be our distance from starting point. Okay? And we can once again use the law of cosines. X is going to be equal to the square root of 2.53 squared plus 1.73 squared minus 2 times 2.53 times 1.73 times the cosine of 150. So we find the square root of 2.53 squared plus 1.73 squared minus 2 times 2.53 times 1.73 times the cosine of 150. So our distance from the starting point is going to be 4.12 miles. So x is going to be equal to 4.12 miles. That's going to be the runner's distance from the starting point. Okay, that is the full video. Have a great night. See, that's the end of the slides.